Welcome back to Exploring Northern Ontario. Today we're not exploring Northern Ontario. We're going to explore the concentrates that I've collected this summer. In this jar is all the fine gold concentrates I've collected this summer. They're mixed with black sands, copper, pyrite, things I just can't remove by panning. The only way we're going to remove that is by doing a smelt. And that's what we're going to do today. Alright, so the first thing we have to do is get the water out of here. So we're just going to put it on a hot pan here. Rinse them out a little bit. Okay. So let's just let that evaporate for a few minutes. Okay, so that stuff is all dried out. You can see some flakes of gold. There's a big flake of gold right there. And there's a whole bunch of very tiny flakes in there. So we're going to take this out and put it in our scoop. Put this over there. All this work is going to be just for this small amount of concentrates. Just put them in this cup for now. Okay, so the first thing we have to do is prepare our charge. Now there's many recipes on how to do a fire assay or a smelt. In this case I'm going to use a standard fire assay. I've done it many times before with a certain amount of sulfide material. I've got recipes, and in fact I'll show you my recipe right here. Okay, this is my standard fire assay recipe that I normally use. Today I'm going to use this recipe. There's many different recipes for smelting, many different types of flux, and actually you should really educate yourself on smelting and fire assay. I really recommend this book, the textbook of fire assay. Now you can read this for a long time and still not become an expert. You have to do trial and error, experiment a lot. So in this case I've done a standard fire assay before with sulfide ore before, and it's worked out fine. Today I'm modifying, like I said, I'm modifying my recipe a little bit to accommodate this like 3 grams of concentrates I have today. And the first thing we're going to do, we're going to add our flux. This flux, it's about 98% lead, and that's going to be our collector metal. The lead, it brings down the melting point of everything. It melts very quickly, and it will collect all of our metals together into one lead button. So we need 40 grams of lead. Oh, there's 44. 44. That'll do. It's not that precise. Now, silica. Silica sand. In this case, it's just quartz. I took some quartz and I ground it up. Silica works as an acid flux. It coats the crucible. It protects the crucible from melting, from failing. So we only need 5 grams of silica. Oh well, that's pretty close, 50. Okay, 6 grams of silica, that'll do. Then we need 18 grams of soda. So it's sodium carbonate. Sodium carbonate, it also protects the crucible. It's actually an alkaline flux, so it keeps the balance of the pH so it doesn't become too acidic and then boil over. It also reduces the melting temperature of the charge. And the last ingredient is we need a source of carbon as a reagent. So flour makes great carbon, and I figured we need about 1 gram of flour for our charge. A bit more. That should be fine. That's plenty of carbon. Now, on top of all of that, let's add our concentrates. Now we'll mix that around really good. So what's going to happen, all of this is going to melt. It's going to become, we're going to pour it into a cone mold, and it's going to be reduced to one little button of lead. Then we're going to take that one little lead button, we're going to put it on a cupel. It's made of magnesium. And when we put this lead on this cupel, it's going to drive off all the lead. Some of it will oxidize, and some of the lead will also absorb into the cupel, along with base metals like lead, copper, zinc. The only thing left will be our precious metals. We'll have a little tiny bead of gold, probably mixed with a little bit of silver, possibly platinum, when we're finished. Okay, so we better preheat our furnace first. You can see I have our furnace. It's very heavy, strategically located on top of a lawnmower, so I can move it around the shop easily because it's quite heavy. Let that run low for a little while. Let it get all the moisture out of my furnace. I haven't run it in a long time, so I don't want anything exploding out of there. So let's just heat it up slowly first. All right, I'm going to place the charge in there and let that slowly start warming up. All right, so it's warmed up enough. Time to turn the heat up. We got to get this up to 2,000 degrees. Take our high-tech air compressor here. Blow some air in there. Nice blue flame. Okay, so this is our cone mold. This is what we're going to pour our molten charge into once it's done. But it's very cold out here in the garage, and to prevent thermal shock, I'm just going to put it up here and let it warm up. I might have that a little bit too hot. I think I'm going to reduce it a little bit now. See, there's little dots of lead floating around on the surface, searching to collect metals. Okay, this has been running for about 40 minutes now. I'm sure that's enough. So let's get ready to pour this. Let's put our mold here. Looks like it turned out okay. The flux seems viscous enough, I believe. Let that cool. And we'll see what we've recovered. Okay, that should be cooled off enough by now. Looks like we've got a very nice glassy flux on the surface. Yeah. There's our lead. You can see the lead. That's our collector metal. Let's clean it up a little bit. There it is. That's our lead button. I'm just going to clean it up a little bit better up here. Get all that glassy stuff off of there. Too bad now there. It's pretty clean. Scrape off some of that. So that's our lead button. So I think I said I put 40 grams of lead in. I only recovered 21 grams of lead. So we'll see, hopefully some of that is gold as well. So it looked like I might have lost some of the lead in the process, I'm not sure. So I'm taking a good look at the flux. And actually, yes, there's a little bit of lead there stuck to it. That's not a good sign because, as you know, the lead is a collector metal. And if the lead was collecting gold, it's possible there might be a little bit of gold that we're losing right there. Otherwise, the rest of the flux looks very glassy. Doesn't appear to be any matte to it. There's no metallics left in there. So as you know, what's going to happen now, this cupel is made of magnesium, and all of the lead is going to be absorbed by the cupel. Some of the lead will also be oxidized, and the only thing that will not be oxidized or be absorbed by this cupel are precious metals, gold, silver, platinum. So let's see what we get. Okay, so we're ready to put our cupel into our little electric furnace. Just drop it in there. And then we'll start heating that up. Okay, let's take a peek. Oh, yes, it's starting to oxidize. Some of the lead is starting to turn into oxides, and you can see it, that smoke rising up. That's not good stuff to be breathing in, actually. It's a perfect puddle, and you can see that lead oxide coming off right now. I think I'll just stop breathing that stuff in now, thank you. You see the lead bubbles whipping across the surface? Our puddle is getting smaller as the lead is being absorbed by the cupel. Okay, let's have another look. You can see all that smoke coming out. That's all the lead. Of course, I shouldn't be breathing that, but I do have a fan and the door's open. Let's have a look. Look at all that smoke. And our bead is very small. It's going to be finished soon. Soon, the only thing left will be our precious metals, our gold, our silver, our platinum. As I mentioned before, this book, this textbook of fire assay, is an excellent book. I'll post it in this video. I'm not an expert in fire assay. For me, it's been a labor of trial and error and watching some really good YouTubers. There's this one YouTuber, I'm going to put the link down at the bottom of this video. I believe he's from Mount Baker Mining and Metals, and he does a lot of experiments with smelting. I've watched a lot of his videos. He's been really informative, and I encourage all of you to watch him as well. I just wanted to mention one thing. When you're nearing the end of the cupellation, you want to make sure that your temperature is extremely high, because now that little puddle you have in the cupel, it's mostly precious metals. And the melting point of those precious metals is a lot higher than the lead that was in there. So it takes a lot more temperature to finish it off. So you want to make sure you keep that temperature really, really high when you're finishing off your cupel. Okay, it looks like we're just about done. There's only a little bead left of gold. Have a look. See how shiny it is? You can see the shine coming off of that? I think that's done. Okay, I'm pretty sure it's done now. Unfortunately, we didn't get a very big bead of gold. We've driven off all the lead. Only thing left, little tiny bead in the center of pure gold. Just gonna let that cool now, slowly. There you go, perfect cupel. See the little prill? It's called a prill of gold. It's well over 99% pure because the magnesium cupel doesn't allow anything precious to be absorbed. All other metals are absorbed. The only thing that could be in that bead could be gold, silver, or platinum. Judging by the color, it's pretty much all gold. Okay, so that'll do it for this video. I hope everyone enjoyed. I think we were very successful with our smelt and our cupelling process. I've done this quite a few times, and we were successful at getting a nice little prill of gold. The only thing I think I have to work on is finding a heck of a lot more of it out in the bush. See you next time.